All right, good evening. Welcome back to PreCalculus with Trigonometry. We are still talking about trigonometric equations, and then this is a slightly different format here. Start factoring on this one. So we have 4 tangent x equals -7. Okay. So we have 4 tangent x equals -7. And they go on to tell us about, well, it should be in radians, and we're going to just give approximation to degrees rounded to 1. Or, give an exact solution in radians. Oh, and give an approximation to degrees rounded to 1 decimal place. Okay, so we'll go ahead and give that. I'm probably going to do it in degrees first, and I'll show you why, because it's easier to think in degrees than it is in radians, especially since these aren't going to be pies. These are just going to be decimal places. And we're going to have some answers here. So what's going on here? We're going to say, well, tangent of x is equal to -7/4. Okay, that's okay. And then we're going to say x is equal to tan inverse of -7/4. The reason I went straight to an inverse function was because we are not required to know this particular fraction. This is not a known angle. This is not an easy angles that we're supposed to know. Okay. But we can go back to our all students take calculus. Where is the tangent a negative number? Well, that's going to be in quadrant 2. It's going to be in quadrant 4. Okay. So what's going on here? So let's go ahead and make sure we are in mode for degrees. They are. Okay, so what we're going to do is we're going to say second function tangent. So we want tan inverse of -7/4. Now tangent inverse gives us a -90 to +90 kind of an answer here. So we got -60.3 degrees. So we have -16.3 degrees to 1 decimal place, x equals. Where is that? Oh, that's here-ish. Okay, here's -16.3 degrees. How would I put this in terms of something that's like between 0 and 360? Okay, so what we're going to do is we're going to add 360 to that. Okay, we got 299.7 degrees. So really, we have a 299. This is 299.7 degrees. Okay, where else, right? Students take all students is B and S. Okay, where else is tangent negative, right? It's negative in the fourth quadrant, but it's also negative in the second quadrant. Okay, how do we cast this angle here at -60? How do I cast it into that angle? Okay. Oops. Drawing at this point. Okay. So we know that this is 299. How do I cast it over here? Okay. So what we're going to do is we're going to subtract 180 from it. So one answer we have is x is equal to 299.7 degrees. 299.7, but I'm also going to subtract 180 from it, and that should give us something in between 90 and 180 here. Okay, so what we're going to do is we're going to subtract 180. Okay, we have 119.7 degrees. So we have 119.7 degrees. That's here. We also have 299.7 degrees. That's there. Okay, so these are the two angles that I would like to know. All right, so if we have this in radians, this is in degrees. Okay, clearly this is in degrees, but I just find it will be a little bit easier to think in radian or think in degrees. What if we didn't have to do 180? We had to do like something from a fourth quadrant to a third quadrant kind of an idea. It's a little bit easier to swing this around in degrees than it is in radians. Okay, we just have to convert this, right? And we just remember that 2 pi radians is equal to 360 degrees. Okay, so if we divide everybody by 360, so we have 2 pi over 360 radians is equal to 1 degree. Okay, all I do is divide by 360. So this is going to be 2 divided by that, so that's pi over 180 radians equals 1 degree. Okay, so just remember that's our conversion factor here. So 1 degree equals pi over 180 radians. Does it make sense that if 1 degree is pi over 280 radians, if I want to go ahead and multiply by 299.7, that 299.7 times 1 degree would be 299.7 pi over 180 radians. Okay, and the same thing, we would have 119.7 degrees is equal to 119.7 degree pi over 1 radians. Okay, so that's just what we're going to do to change that as into radians. That's what they wanted. Okay, if you're one of my students in a face-to-face class, I'd probably not ask you for this. Okay, degrees will be just fine. But since Alex is in charge, we will apply. We'll obey. Okay, so what I'm going to do is I'm going to take this 299.7 divided by 180 divided by 180. Okay, so I got 1.665. 1.6665 pi radians. Okay, and then what's the other one I have here is I have 119. Oops, let's get our calculators out. Okay, so we have 119.7 divided by 180. .665, so 665 pi. So, oh, and then comma. I don't know, I'm not feeling give an exact solution in radians and approximation degrees rounded at 1 decimal place. Sometimes they want the pi here, sometimes they don't. I'm a little confused as to what exactly they want. If they want the pi in here, we'll leave it as is. Okay, but if they don't want the pi in there, we can just multiply this by pi and come up with a number that's 4 decimal places. Either way. Oops. 665 pi, and we'll see. Okay, so we'll check. I'm not that confident as to what's going to happen here, so we'll type that in. It didn't like it. Okay, so we'll change our mind to say, okay, well, we want 299.7, 299.7. Okay, oops, 7.7. Sorry about this, 0.7, come on. Okay, times second function pi. Okay, and then they don't want the pi, they just want what's going on. Okay. So we'll just go ahead and do that, 299 times pi divided by 180. So they just want 5.23, okay. So we just want 5.2, that's in radians, okay. And then we're gonna take 0.665, we want 119.7, okay, times pi divided by 180. And we got 2.1, okay, 2.1. Again, that's with the radians. So we'll double check and we'll see. Okay. 2.1, 5.2 and 2.1. Okay. So we will start over. We'll do 5.2 and 2.1. 5.2, comma, 2.1. Check this. Still didn't like it. Let's try a different way. Tangent of what? Negative 7/4. Let's go back to mode. Hit radian. Quit. Enter. All right. And they wanted this between 0 and 2 pi. So I have negative 1.05. Okay, where is this? That's what we want. Negative 1.05. Let's just add 2 pi to it so we can get it as a positive number and see what happens. So we're just going to add plus 2 times pi, 2 times pi. All right, we got 5.2. All right, I'm pretty happy with that. Okay, and then that's 5.2 here. There we go, that's 5.2. And I'm just going to subtract pi from this, okay? So we're just going to go back to here, and I'm going to subtract pi and get 2.08, okay? 2.1, which is what we have here. One decimal place. All right, so we double checked it. It is not exactly what I'm looking for. So let's recheck this one last time. Well, they wanted the exact solution. Okay. So that's effectively what we did. Okay, that's a little sneaky. Approximation for the solution sets of degrees are. Guess we could check these guys over here. Okay, and say this is going to be 299.7 degrees. So we'll type this in as 299.7. All right, and then 119.7. Right, if they had given me, I'll give the exact value, exact solution radians. Okay. And they give the approximation to degrees rounded to 1. All right. So they got me because I didn't read that exact value well enough. Okay. But if they want exact, we're just going to leave it as arctan or tan inverse. If they want it to 1 decimal place, we'll go ahead and do this to them. Okay, so my apologies for that sneaky little wording to get us to get the right answer. That's okay. That's okay. Won't get caught next time. But there we are, and that's problem number 10. So we'll see what we have with that one. Okay. Thank you for tuning in, and I'll see you in the next video. Thank you.